Lesson 2, practice problem. This is from Unit 4. Number 1. A cyclist rode 3.75 miles in 0.3 hours. How fast was she going? When I do these problems, I like to, it's because it's asking for miles per hour, and that's exactly kind of how you want to set it up as a division problem. So, miles, 3.75, divided by hours, 0.3. 3.75 divided by 0.3. So when you do that, you get 12.5. So we're going to get 12.5 miles per hour. Okay? So every hour, she's going that fast. Or that distance, I should say. At that rate, how long will it take her to go 4.5 miles? So, now that we know her unit rate, now that we know that, we could pretty much figure out anything. So we just have to multiply it by 12.5. So for this one, we're going to do 4.5 times 12.5. So 4.5 times 12.5. And that means that she can go 56.25 miles. All right, so that was just a matter of multiplying the unit rate by the distance. All right, moving on to number 2. The recipe for sparkling grape juice calls for 1.5 quarts of sparkling water and 3/4 quarts of grape juice. Part A, how much sparkling water would you need to mix with 9 quarts of grape juice? Okay, so in order to figure this out, we need to know what's the scale factor. What scale factor do we need to use, okay? So what is the scale factor? All right, in order to figure out the scale factor, let's compare the number of quarts that are being used in this recipe, which is 9, to what was used in the original recipe, which is what are we doing? Grape juice. So for this one, we're going to do 3/4. So we're going to do 9 divided by 3/4. So 9, put 9 over 1, divided by 3/4. Keep the first fraction the way it is. Change division into multiplication. You got 4/3. And then 9 times 4 is 36. 36 divided by 3 is 3. And then that equals 12. All right, now it seems like we did a lot of work, and it seems like we're done, but we're not. That just gave us our scale factor. So our scale factor is 12. Okay? So that is our scale factor. All right? And the scale factor is important because now that's going to tell us what to multiply the amount of sparkling water by. So we're going to do 1.5 times 12. Now 1.5 really is 3/2 times 12 over 1, which equals 36 over 2, which equals 18. So that's going to equal 18 quarts. So finding that scale factor was important. Now let's go ahead and do the same thing for B. This time we're doing it with sparkling water. So let's figure out the scale factor for that one. So let's do 15/4. Let's set up a little bit of a complex fraction here. So we're going to do 15/4 here, divided by the original mixture of sparkling water, which is 1.5. Now I'm going to put 3/2 there instead of 1.5. So this is a matter of doing 15/4 divided by 3/2. Change division into multiplication and then flip the second fraction. Keep the first fraction the way it is. And then we can do some cross canceling here. 2 and 4 become 1 and 2. 3 and 15 become 1 and 5. And so there we go, we got 5 halves. Okay, now keep in mind that 5 halves is the scale factor. That's not the number of quarts. That is the scale factor. All right, so the scale factor is 5/4, or 5 halves. All right, so let's go ahead and multiply the grape juice, the amount of grape juice that you need, which is 3/4 by 5 halves. So we're going to do 3/4 times the scale factor, which is going to be 15/8. There you go. So that's going to be 15/8 quarts. So this next one's a little tricky because it says how much of each ingredient would you need to make 100 quarts of sparkling grape juice. Okay? Now this is not asking us like about just how much sparkling water do we need. It's not asking us how much grape juice. It's asking us how much total, how much we're going to need for everything. So the 100 quarts of sparkling grape juice is a combination of both ingredients. All right, so it's both. So if we go down to the simplest form, 1.5 plus 3/4, and we add that up, 1.5 plus 3/4, that's 2 1/4. That's 2 1/4. All right, or 9/4. All right, so what I'm trying to show you here is that just the basic mixture makes 9/4, 9/4 quarts of sparkling grape juice. Okay, so just like we have been doing on the other two problems, let's find the scale factor. So we're going to do 100 divided by 9/4. Nothing cross cancels very nicely on this one, so I get 400 nights. Okay, so there's our scale factor. So our scale factor is going to be 400 nights. That means we're going to multiply all the other ingredients by 400 nights. All right, so let's do the sparkling water. So we're going to do 1.5 times 400 nights. So 1.5 is really 3 halves. So we're going to do 3 halves times 400 nights. So we can do some cross canceling on that one for sure. The 3 and the 9 can be both divided by 3. And 400 and 2 can both be divided by 2. All right, so then we're left with 200 thirds. Quarts of sparkling water. Okay, so that one's done. All right, now let's do the same thing to the grape juice. Now we're just going to do 3/4 times 400 nights. And just like on the last one, we can do a lot of cross canceling. So 3 and 9 can both be divided by 3. And 400 and 4 can be both divided by 4. And so we're left with 100 thirds quarts of grape juice. So that's what you're going to need of each type. So we're going to need 200 thirds quarts of sparkling water, and you're going to need 100 thirds quarts of grape juice. All right, for number 3, at a deli counter, someone bought the following stuff. All right, so the question is, which meat is the least expensive per pound? Which meat is the most expensive per pound. So we're just finding unit rates on this one. So we're going to find unit rates. So we're just going to do, out of all these, we're just going to do 14 and a half, $14.50 divided by 1 3/4. Now 1 3/4 is really 1.75. And so that will make it easier to do the math here. And I'm going to need to round this, but it comes out to 8.285, so I'm going to round that to about $8.29 per pound. Okay? So that's what that one came out to. I'm going to do the same thing with the turkey. So we're going to do 26.25 divided by the weight, 2.5. So 26.25 divided by 2.5 is $10.50 exactly. So right now, ham is in front. That's the cheapest one per pound at least. And turkey is most expensive. We only have two things though. All right, next one we're going to do 550 divided by 3/8. Now 3/8 is 0.375. Right? 0.375. I just do that by dividing. So do 550 divided by 0.375. And I get $14, and if I round it, 67 cents per pound. All right, so the least expensive, what's the least expensive per pound? All right, that is going to be turkey. That's usually the least expensive. That's going to be the least expensive. The most expensive per pound? Most expensive is the one we just did, the roast beef. All right. Part A for number 4, draw a scaled copy of the circle using a scale factor of 2. So that means we want to double it. We want to double it. So everything about this circle, well, at least the dimensions of it, the radius and this diameter, are going to be twice what they were before. So what I'm going to do, I'm going to go to my drawing tool here. I'm going to draw a circle, and I know it's not perfect, but what I'm going to do is I'm just going to try to draw a circle here. And try to avoid drawing an oval. This doesn't make a perfect circle. But I want to make it so like, because like right now, the diameter is, there we go. Like right now, the diameter, that's 1 to 1. So I want to double it. So I'm going to do this. And I'm going to kind of estimate when the diameter is kind of in the middle. And it looks like it's in the middle right there. I don't know, let me see. Now that looks longer. Let me shorten it up a little bit. So yeah, so like right there, I would say that diameter is equal to that, or now to radius, but the diameter is now equal to the radius of the new circle, and that's double. There we go. So there's what it looks like if I kind of center it, I guess. All right, how does the circumference of the scaled copy compare to the circumference of the original circle? It should be double, right? Should be double, because since that's how it works. So if the diameter of the original circle, I'm just going to make up a number here, but if the diameter of the original circle was 1, all right, the diameter of the new circle is going to be 2, right? It's double. So this one would be 3.14 times diameter, which is 3.14 units. Okay? Now this one's going to be 3.14 times 2, which is going to be 6.28 units. So that's double. Double. All right. How does the area of the scale copy compare to the area of the original circle? Now, if you know anything here, if you remember anything, you'll know that area is not proportional. It doesn't mean, like, it means that we're not going to, just like we did for circumference, we multiplied by 2. That does not work for area. That does not work for area. So let me go back to those same numbers. So now we want to know the radius. So the radius is 1/2 on this one, and the radius on this one is 1. Okay? So to find area, or to find area of a circle, we're going to do pi times radius squared. So we do 3.14 times 1 squared on the other one. So it's going to be 3.14 times 1/4. 3.14 times 1 on that one. So 3.14 times 1/4 is 0.875, or 0.785 square units. And then for this one, it's going to be 3.14 pi square units. And if you want to know how these relate to each other, that is times 4. That is times 4. And the reason we know that, because the way the relationship works is that it's going to be, the scale factor squared. So you're going to take the scale factor and raise it to the power of 2, which makes 4. Okay. So that's 4 times larger. Jane has a scale map of Kansas that fits on the page of her book. The page is 5 inches by 8 inches. So it's not a very big page. Kansas is about 210 miles by 410 miles. Select all scales that could be a scale of the map. All right. So it gives us a hint that there's 2 and 5,400 centimeters in an inch. Okay, so this first one right here, I'm going to throw that one out right away, because 1 inch to 1 mile, that means every inch equals 1 mile. That means your map is going to need to be 210 inches by 410 inches. Okay, we only have a 5 by 8 page. So get rid of that. And same thing for B, for the same reasons. 1 centimeter equals 1 kilometer. Now, 1 mile equals I think it's like roughly 1.6 kilometers. So that's going to even be more. So yeah, let's get rid of that. 1 inch to 10 miles. Well, it's kind of breaking it down more. Well, so that means if we divide 210, if we do 210 divided by 10, that's 21 inches. So that's smaller. It's much smaller than 210 inches, but still not small enough to fit on the page. All right, 100 feet, or 1 foot to 100 miles. All right. So that's not going to work, because that right there is one foot. So we're going to need a page that's bigger than 1 foot. That's not going to work. All right, 1 centimeter to 200 kilometers. That one I think should work. That one's going to work. And 1 inch to 100 kilometers will work. And then, because those will be small enough. And then for the last one, that one should not work. That's going to be way too small. That's like if your page was to look like this, your map would probably look like that small. I'm probably not estimating that right, but it would be really small. You need to use up more of the page than that for your map. All right, it definitely fits on the page, but it just doesn't seem very realistic. Whereas these two fit on the page, you know?